So before we go into the actual lesson for today, we're going to go over the warm-up, okay? So what I'm going to do with you guys is I'm going to work this by factoring that square root of 32. So the first thing I'm going to do is put the square root of 32 up here like this, and then I'm going to factor it. Now, hopefully all of y'all can see that that's an even number, so I know for sure 2 goes in there. So I'm going to put 2 here, and 2, and what you can do with your calculator is just divide 32 by 2, and that's 16. Now, we could keep going with this with our 2's, or you can recognize right now that 16 is a perfect square, okay? So let me show you. So we could stop right here and say the square root of 2 and the square root of 16, right? So that's going to end up being 4, and that's still going to stay the square root of 2, so that's going to be 4 square root of 2, okay? Now there's another way to do this. So that's our answer. We're going to say that, okay? But I'm going to show you another way. So I could keep going with this, okay? So I can keep going down 2, 8, 2, 4, another 2 and 2, right? Here, let me move it over. So now when we do this, we're looking for even numbers of things, okay? So notice we've got 5 2's. So there's a pair, there's a pair. That's 4 times 4, right? Which is what? Your 16. That's what kind of tells you that this is a perfect square, okay? That's a trick. All right, now let's go to this other one over here. So the 88. We're going to do the same thing with it. So I'm going to do the square root of 88. And again, I know that that is divisible by 2 again, right? So I'm going to do 2. And that's going to give me 44, right? And then I'm going to factor it again, because again, it's still an even number, so I'm going to do that, and that's going to give me 22. Now, that's still factorable by a 2, right? So that's going to be 2 and 11. See it? Okay, again, remember, we're looking for pairs of numbers here if we're looking for a perfect square, right? So notice we've got 2 2's right there, right? So we're going to take those and we're going to put those back under the square root. So that's going to be the square root of 4, right? Because that's 2 times 2. And then we're going to take these 2 and put them back under there. The square root of 22. What's the square root of 4? Yes, it's 2. So this is going to be 2 square root of 22. So that one was D. So now, guys, we're going to go on to the next slide. So let me go up here. So now we're going to go into our lesson today, which is M1.1, okay? So it's on imaginary numbers. And so by the end of today, we're going to know that there is a complex number, I, such that I squared equals -1, okay? That's what we're by the end of the lesson today, this is what you should be able to do. So here's our review. If your teacher went over the pretest with you, then you probably saw a little bit of this then, okay? So what we're going to do is we're going to use some of these properties. Notice the properties in the upper right-hand corner. So if I have the square root of the square root of A times the square root of B, I can take those and put them underneath the radical, right? So I can do A times B, all right? Now, the other thing you need to notice is if I have the square root of A over B, then I can separate those. So I can take the square root of A over the square root of B. Did everybody see that? All right, so what we're going to do with this first problem over here then is we're going to actually separate it. So we're going to take the square root of 108 over the square root of 25. Now, most of you can see immediately that the square root of 25 is 5, right? But we're going to have to do a little bit of work on that 108. So let's do what we did before, which was take that 108, and we know again, it's a what? It's an even number, so we're going to divide it by 2. So that's going to give us 54. And we're going to divide that 54, again, another even number. Let me take this over here. And that's going to give us 27, right? And now we have, I know that that's divisible by 3, which gives me 9 and another 3 and a 3. So remember I told you guys earlier that we're looking for pairs of numbers, right? That's what's going to tell me if this is if this has got a perfect square as a factor. So we got a pair of numbers right there, the 2's, and we got a pair of numbers of 3's right there, right? So what is 2 times 2? Yes, it's 4. And what is 3 times 3? That's 9. So that's 36. Y'all see that? That's a perfect square, right? And then what do we have left over? We have this little 3 down here left over. Y'all see that? So, and we've factored everything, okay? So this is going to be the square root of 36 times the square root of 3. That's equal to 108. What's the square root of 36, y'all? Yes, 6. So this is going to be 6. Pause, y'all. My thing just died. Okay, I don't know what's going on. So then it's times the square root of 3. So that's going to be our numerator up here. 6 square root of 3. And then we know this square root of 25 is 5, right? And that's as simple as that can get. We can't reduce that anymore, okay? But that's the answer. Any questions? All right, so now we're going to do this one. Leave the 6 on the outside. Again, we're going to factor this. 45. So I know that it's divisible by 5. I'm sure y'all do too, right? 5 times what is 45? 9, right? So guess what? That's a perfect square. How do I know that? 3 times 3, right? So once again, I'm going to take this and this, put them underneath the radicals. So I'm going to keep the 6 on the outside. So that's 6 times the square root of 9 times the square root of 5. So this is going to be 6 times 3 square root of 5. So that's going to be 18 square root of 5. Okay? Last one over here. Again, we got the 1/2 out front. We're going to take square root of 48. So here again, I know this is divisible by 2. So that's 24. Again, 2, 12, 2, 6, 2, and 3. Okay, remember about our pairs, right? Okay, so we got a pair here. That's 4. Another pair right there. That's 4. Y'all, what's 4 times 4? 16. Oh, perfect square, right? Okay. So this is going to be 1/2 times the square root of 16, and we got that 3 still down there, times the square root of 3. So this is going to be 1/2 times 4 times the square root of 3, which means half of 4 is 2, right? So this is going to be 2 square root of 3. Okay, let's see if I can get this thing to go to the next page, y'all. So this is how many solutions does the graph of f of x equals x squared plus 1 have? So the first thing I got to do is see if you guys remember how we can tell by looking at a graph what the solutions are. So if you guys recall, when a graph crosses the x-axis, that's how we can determine if it has solutions and how many solutions, okay? So does this graph f of x equals x squared plus 1 cross the x-axis? No. So according to this equation, what we see here, how many solutions does this graph have? It has none. So then it says, let's solve the corresponding equation. So what we're going to do is we're going to take this equation, 0 equals x squared plus 1, and we're going to solve it. So what do we do first? We subtract the 1 from both sides, right? So we got -1 now equals x squared. How do we get rid of an x squared, guys? Yep, you got it. We're going to take the square root of both sides, right? So now we have x equals the square root of -1. So prior to this point in your math life, could you take the square root of a negative number? No, you could not. So this right here is where we start to see the concept of imaginary numbers. So what I'm here to tell you today is that the imaginary unit I is defined as the square root of -1. So that means when I have the square root of -1 like I do up here, that's equal to I. So I is equal to the square root of 1. Everybody say that. I is equal to the square root of -1. This is the new concept for the day right here, y'all. That's it right there, okay? Most everything else we're going to do today is, not everything, but most of everything else we're going to do today is old stuff, but this is the new stuff, okay? So down here it says you can use the imaginary unit to write the square root of any negative number, and that's what we're going to do next, okay? So an imaginary number is the square root of a negative number. So we're going to write square root over here of a negative number. Okay, so i.e. the square root of -1 is I. That's what we just talked about, right? Then it says if b is a positive real number, then the square root of -b is, watch this, the square root of -1 times the square root of b. Well, what's the square root of -1, y'all? Look over here. Isn't it I? So this is going to be equal to I square root of b. See it? So the next thing that we're going to go over here is the imaginary numbers can be written in the form of bi, where b is the real part of the number and I is the imaginary unit. Okay, so now we're going to do this with a couple numbers, okay? So once again, because we've got the square root of -2, I'm going to take the square root of -1 and I'm going to take the square root of 2. Once again, we know that the square root of -1 is I. So this is going to be I square root of 2. When we do the square root of -4, again, we're going to do the square root of -1, and then we're going to take the square root of 4. Well, hopefully all of y'all know the square root of 4 is 2. So this one is going to be 2i. And I always put the coefficient first because this is just like when we say 2x. So even though you could say I times 2, we're going to say 2i. So now when we get over here to the right and it says and the square root of -b squared, okay? So on this one, again, we're going to do the square root of -1 and we're going to do the square root of b squared. Hopefully you guys know that the square root of b squared is b, right? So here we go. The square root of -1 is I. The square root of b squared, these cancel each other out, don't they, y'all? So this is going to end up being bi, because again, that b is going to be like the real part, where I is the imaginary part. All right, let's do the last one. The square root of an imaginary number, so this is the square root, I guess the square, sorry, the square of an imaginary number is the original negative number, okay? So what does that mean? So you guys should know that when you take the square of a square root, it cancels out the square root, doesn't it? So I'm going to show it here. -1 squared, right? So these two things, they cancel each other out. What are we left with? That -1. So over here, okay, this time we're squaring the square root of -b, so it's going to be the same way, y'all. So again, we can cross that out, that the square root and the square cancel each other out, so we're just left with the -b. Hopefully that makes sense. If not, it will in a minute. All right, so now we're just going to work some problems, guys, okay? So it says simplify the square root of negative numbers, express the number in terms of I. So what we're going to do here is, once again, if you recall what I did before, I'm going to factor out the square root of -1 and then leave it the 121. Hopefully you guys know that the square root of 121 is 11. So once again, this is 11 and I, but remember I said we were going to put the real part first and the imaginary part second, so it's going to be 11i. When we do this one, minus, isn't that going to be a -1 out there, y'all? Okay, so we're going to do the square root of -96. So this is going to be what? The square root of a -1 And here again, we're going to factor it. Now, I'm pretty sure 3 goes in there. So we could, again, take it up here, 96, 3. That would be 32 divided by 2. That's 16. I see a square right there. Do y'all see that? 16. That's a perfect square, right, y'all? So I could take this one and then this one and this one and put them under there. So that would be the square root of 3 times 2 and the square root of 16. Do y'all see it? So this is going to be I, right? This is going to stay the square root of 16. This is going to end up being 4, right? So we're going to take this 4 and this I and put them together. So this is going to be 4I square root of 6. So I forgot something. Do you guys see what I forgot? Yep, that -1 right there. So I got to multiply that -1 times the 4I and the square root of 6. So my answer is actually going to be -4I square root of 6. That's my answer. That was my answer over there. Okay. All right, let's do 1C. So we got our 5 out here. Now, I'm pretty sure all of y'all can see that 125 has got to be divisible by 5, right? So here we go. We're going to go 5 and 25. Y'all see that? So we can put both of those underneath the radical right now because 25 is a perfect square, right? So this would be simplified to be 5. And I'm going to go ahead and put that square root of 25 next because we're going to simplify that and leave that square root of 5 underneath there. So this is going to end up being 5 times 5 square root of 5. 5 times 5 is 25. And that's the square root of 5. Okay? So this last one, example 1D. So this is 1/4. Again, wait a minute. Does y'all say negative on your paper? Because mine doesn't say negative. That should have had an I on it, right? I don't know how that got messed up, but it should be negative there. Yes, y'all see it? On y'all's paper, it says negative, so we missed the I. It's down here, okay? Because this would have been the square root of -1. Got it? Okay, so now, again, square root of -1, square root of 128. I know that that's a even number, so I'm going to do 2 here, 2 times 64. 64 is a perfect square, right, y'all? Okay, so this is going to be, so that's going to be 1/4 times I times the square root of 2 times 8, right? What's, let's do it like this. 1/4 times 8. I square root of 2. So now, can't we do 8 over 1 times 1 over 4? Isn't that going to be 8 over 4, y'all? It is. So this is 8 divided by 4I square root of 2. So what's 8 divided by 4? Yep, 2I square root of 2. Okay. So the next group of problems I want you guys to try, okay? So go ahead and try this one. Pause the video, come back to me when you're done. Okay, so on this one, this is a pretty easy one, y'all. So we're going to do the square root of -1 times the square root of 64. Hopefully you know that the square root of 64 is 8, right? So this is I, 8. Remember, we're always going to put the real part first and the imaginary part second. So these are going to be multiplied by each other. So this is going to be 8I. Got it? You can do it the other way around too, y'all. If you want to put the square root of -1 after, you can do that as well. So, but I always like to deal with it first because I don't want to forget. So here we got 3. And again, you can pause the video here, come back to me when you're done, okay? So this is going to be the square root of -1 times the square root of 75. I know that that is, hopefully all of y'all know that that's 3 times 25, okay? So I hope. 75 cents, you got 3/4, right, y'all? So that's going to be 3 and 25. So here we go again. So we can simplify this. That's going to be a 5, yes? And we can simplify this. This is going to be an I. So that's going to be 3I times 5, and we still got this right here, right? So that's going to be the square root of 3. So let's simplify the thing. 3 times 5 is 15. So it's 15I square root of 3. And yes, I'm doing this in different orders because some of y'all will, okay? There's not one way to do this. There's many ways to do this, okay? All right, let's see if you guys can do these last three. Pause the video, come back to me when you're done. So here we go again. Square root of -1, square root of 4, square root of 3. I did that because I know 4 times 3 is 12, and I also know that 4 is a perfect square. So this is going to be my I again. 2 square root of 3. Let's put it in right order. 2I square root of 3. This one, pretty easy. 2 square root of -1, square root of 36, right? So this is 2 times I times 6. 2 times 6 is 12. 12I. This one is -1/3, square root of -1. I just happen to know that 9 times 7 is 63, y'all. So square root of 9 times the square root of 7. So this is -1/3. Again, I got my I here. I've got 3. And I still have my square root of 7. So I'm going to combine those two. So that's, again, a -1/3 times a what? 3 over 1. I square root of 7. So this is -1. Actually, it's going to be -3 over 3, right, y'all? Because remember, you multiply across top and across the bottom. I square root of 7. So isn't that just going to be -1 times I square root of 7? So that means this answer, y'all, is just -I square root of 7. That's it. Okay, so now in this part of the lesson, we're going to talk about the cycles of I, okay? So the imaginary unit I can be raised to higher powers as shown below. So we're going to complete this table. So anything to the 0 power, y'all. So I to the 0, that's going to be equal to 1, right? Because anything to the 0 power is 1. So that's what this is going to be over here is 1. I to the 0 is 1, okay? Now, remember, I is the square root of -1, right? So now again, when we take anything to the first power, what do you know? You know it's that, right? So this is what I need you guys to understand. The square root of -1 is equal to I, right? And anything to the first power is still I, right? So this is I. And I'm just reminding y'all that the square root of -1 is I, because we're going to use it in just a second. It's going to become important in the next one we do, okay? This is why. So now we have an I squared, right? So what does that really mean? That means that we are taking the square root of -1 times the square root of -1, aren't we? Because isn't that what I is? We got this squared, right? So what does that mean? That means we've got the square root of -1 squared, right? Because there's 2 of them, squared. So what does that do to those 2 things underneath the square? What does the square root do to the square? That's what I'm asking y'all, okay? I actually put 1 extra one out, I didn't mean to. What does the square root do to the square, y'all? We talked about this earlier, right? Don't they cancel each other out? So what are we left with? -1, okay? Now, let's talk about what I to the 3rd is. This is the way I think of it. It's just I to the 2nd times I, right? So what was I to the 2nd? It was -1. And what was I? It's just I, right? So you're multiplying -1 times I, so that's a -I. So notice now we have a cycle. It's 1I, -1, -I. So now let's look at this x to the 4th. Okay, so what is x to the 4th? X to the 4th is simply I squared times I squared, right? So what was the I squared? Look back up here. Wasn't it -1 times -1, which is what? 1. Do you notice, guys? It repeats. So when we get to I to the 4th, it was the same as I to the 0. This pattern works, keeps going, right? So when we look at I to the 5th, what do y'all think it's going to be? Look, what was I to the 1st? Isn't it going to be I? Because I to the 5th would be right here, right, y'all? What is I to the 6th? What was the next term after the I? -1. What was I to the 7th? What was after the -1? Negative I, right? And then I to the 8th is going to be equal to that 1 again. Y'all see the pattern? So this pattern keeps repeating every 4 numbers, okay? Now I'm going to teach you how to figure out what, we're going to teach you this method called the quarter method, okay? So the quarter method is when you ask to simplify I of a higher degree, like maybe in the teens or in the, like a 40 something or 100 something or a 500 something power. Y'all got me? That's when we use this quarter method, okay? So one of 4 options is always going to be true, and we're going to divide the exponent by 4, okay? So, and we're going to look at this on our calculator, and we're going to look at the remainder. So you're going to ask yourself, how many quarters go into the remainder, okay? So if the remainder is 25 cents, then 1 quarter goes into it, so you're going to use the 1 as the exponent, so it's going to be I to the 1st. So I'm going to actually, before I work a couple examples, let me pull this down, see if I got some space. You know what, I'm going to go back to the previous slide and show you out here because I got open space over here. So I'm going to erase this and I'm going to show you some examples here, okay? So I'm just going to start with I to the 12th, okay? So if I had I to the 12th here, this is what I'm going to do. Everybody listen, watch, okay? So I'm going to take this 12 and I'm going to divide it by 4. So what's that give me? 3.0. So we're looking at that remainder, right? So there's no change. Y'all see that? So that's going to be I to the 0, which was what, y'all? 1, right? See it? Now let's just do I to the 13th because you'll see the pattern here, okay? So that's going to be 13 divided by 4. So isn't that going to be 12? So 4 goes in here. How many times? 3 times, right? With the remainder of what? So that's 12, 10. How many times does 4 go into 10? How many times? 2, right? So that's going to be 8 with the remainder of 2. How many times 4 go into 20, y'all? 5 times, right? So how many quarters is 25 cents, y'all? Because we're looking at this remainder again right here. How many quarters is that? 1, right? So that means this is going to be I to the 1st, which is what? I. You see it? Okay, let's do one more. I don't want any deer in the headlights here, so I'm going to do one more. So we're going to do I to the 14th. Okay, so again, we're going to do the same thing here. 14, we're going to divide it by 4. You're always going to divide it by 4, y'all, because there's 4 quarters in a dollar, okay? So once again, 3 goes in here, right? We get 12. We got 20 remaining this time, right? Bring down the 0. So that's 50 cents. How many quarters are in 50 cents? Or how many, yeah. How many quarters are 50 cents? 2, right? So this is going to be I squared. Y'all, what was I squared over here? It was -1. So when you guys are doing these kind of problems, I would probably create this table first of these 4 right here. Y'all see these 4? I would create this table on my paper somewhere. If I'm doing this, like if I'm doing a quiz, or actually not a quiz, y'all be able to use your notes for a quiz, but a test, I'd create that table first. And I would use it. Because you got 0, see that 0? That's 1, that's no quarters, that's 1 quarter, that's 2 quarters, this is 3 quarters. Y'all see what I'm saying? So if I got 75 cents here, that would be my 3 quarters. All right, so let's go do let's do some of these examples now. All right, so I'm going to do it like this. So I got 99. What am I dividing 99 by, y'all? What am I dividing it by? 4, right? How many times 4 go into 9? You know what? I need some more space. Let me go down. I made that too close. So I'm going to do 99 divided by 4. So it goes in there 2 times. That's 8. And then I got 19, right? 4 goes into 19 how many times? And y'all can do this in your calculator. Y'all know that, right? 99 divided by 4. You can do this in your calculator. You don't have to do it the long way, right? So if you divide 99 by 4, you're going to get 24.75. How many quarters is 75 cents, y'all? Isn't it going to be 3? So it's I to the third. Okay, let's go back to the previous slide because that's where we had our little table, right? What was I to the third, y'all? Right here. Negative I. So that's my answer. See it? Okay, now we're going to do, this time, just take the 17, y'all, on your calculator divided by 4. 17 divided by 4, what is that? 4.25. How many quarters is 25 cents? 1, right? So that's going to be I to the first, which is what? Just I. Y'all see it? This next one, 120 divided by 4. That's 30.0. So what do I get for change? That's going to be I to the 0. Guess what? That's just 1. Y'all starting to see this now? What did I forget, y'all? Did y'all notice this 4 out front? So I still got to multiply that by 4. So the answer is going to be 4. Okay? Little hint for the last one, right? So this one is 1/4. And then we're going to multiply that by whatever we get for the I. So here again, 64002 divided by 4, right? That was 1600.50. That's 2 quarters, right? So this is going to be I squared, right? Do you remember what I squared is? If not, go back here and look at your table. I squared right there, right? See it right there? So that's -1, right? So I squared is -1. So we're going to do -1 times what? 1/4. So the answer is going to be -1/4. Got it? All right, now we got some U tries left. So let's see if you guys can do these on your own. Come back to me when you're done. Okay, so here's our process. 14 divided by 4. That's going to be 3.5. 50 cents is 2 quarters, right? So that's I squared, and that was -1. 63 divided by 4. That's going to give me 15.75. That's 75 cents. So that's I to the third. If you don't remember, go back and look at your table. This one's going to be -I. Now we got the 12 out front here. So remember, we're going to have to multiply that by whatever we get ultimately, right? But we're still going to do 7 divided by 4. That's going to give us 1.75. That's 3 quarters, right? So that's going to be I to the third. Didn't we just have I to the third just a second ago? I think we did. Yes. So isn't this going to be 12 times what? -I. So that's going to be, is that right? On y'all's paper it says 1/2, doesn't it? It does. This says 1. This says 12 on mine, and this one says 1/2 on y'all's paper. Wait, pause. Attention, y'all got to bring stuff to my attention when I make mistakes like that. So that's just going to be 1/2, right? -1/2 I. Yep. Okay. And then the last one, 42 divided by 4. That's going to give me 10.5. That's 2 quarters. So that's I squared. And I squared was equal to what? -1. And then remember, we still got to multiply by that -6. So we're going to do -6 times -1. So that's going to be 6. Okay, guys. Hopefully that helps everybody.